Hello everyone. We come back to complete 1.5 quadratic equations. We already went over different methods on how to solve quadratic equations, factoring, square root property, and completing the square and quadratic formula. In this video, we're going to focus on something very specific. It's use the discriminant to determine the number of solutions and type of solutions, and also we're going to determine the most efficient method to use when solving quadratic equations, and also we're going to solve some problems models by quadratic equations. So discriminant. What happened from the previous, if you watch the previous video, I strongly advise you to go and look for 1.5 quadratic equations part 1. We solve quadratic equations using a variety of techniques, but we focus on the part b squared minus 4ac in the formula, because in the formula, anytime you see this part, it will tell you how many solutions you can have. So when solving equations, we need to pay attention to this one. Pay attention if b squared minus 4ac is either 0, is equal to a positive integer, rational numbers, or positive real number, or if it's equal to a negative number. So these, based on the answer for the part b squared minus 4ac, you would figure out the number of solutions we're gonna have for this one. All right, so we can find a solution for a quadratic equation of the form ax squared plus bx plus c using the quadratic formula, because that's what we're talking about right now. So once we do that, the discriminant is the quantity b squared minus 4ac, which appears under the radical sign in the quadratic formula. So the discriminant of the quadratic equations determine the number of solutions and the type of solutions you have. Let's see it. If the next slide, we said if the discriminant, that means the b squared minus 4ac is positive, there will be two unequal, unequal real numbers. So if you have that, we're gonna have two unequal real numbers. If the discriminant is 0, there is only one real solution. If the discriminant b squared minus 4ac is negative, then there are two imaginary or complex solutions. Okay, so we're gonna have two imaginary or complex solutions depending on what we have. Look at that closer within examples. We can have any examples in this case. If you look at A, I'm gonna make space and solve like we do with the other ones. Okay, let's solve here. We said, oops, no, you don't want to do that, right? Okay, how are we gonna solve here? Okay, first of all, to solve these equations using quadratic formula, we need to identify what is A, what is B, and what is C. All right, now we know the formula to quadratic formula is minus b plus n minus square root of b squared minus 4ac over 2 times a. Okay, now they said compute the discriminant and determine the number of solutions. All right, they don't really ask us to solve this equation. They said find the discriminants and decide how many solutions we have, right? So in this case, we're going to do only b squared minus 4ac. Let's see what it is. B squared is negative 7 power 2 minus 4 times 2 times negative 4. So what is this discriminant is that is 49. 4 times 2, 8 times 2, 32, right? We add because two negative in multiplication become positive, right? So when you have 49 plus 32, it gives you positive 81. So this is what happened. Because the discriminant is what? Is 81. How many solutions we have? It is positive number, right? So we can say discriminant positive 81. It's greater than 0, right? Here, you see b squared minus 4ac is really greater than 0. What we have, there are two rational solutions, okay? So that's an example, because the discriminant is positive, we have two rational solutions. But if we look at the next one, I'm gonna try to see if it's possible to do for the next one, okay? Let's do some space for this one. Maybe we need to do different ways. All right. Now, if you look at this one, A equal 1, B equals 6, C equal 9. If you do B squared minus 4AC, it gives you 6 squared minus 4 times 1 times 9. So it gives you 36 minus 36 is 0. So you end up having B squared minus 4AC is equal to 0. How many solutions we have? Discriminant equal to 0 in this case. What's gonna happen? Do you know it? What happened? Yes, so because discriminant is equal to 0 shows that there is only one real number solutions. Okay, there is b squared minus 4ac equal to 0. There is only one real solutions. So it can be a rational number, right? Now, for the third one, need space. I'm gonna erase all of this. Okay, for the third one, we see A is equal to 3, B equal negative 2, C equal positive 4. B squared minus 4AC would be negative 2 squared minus 4 times 3 times 4. That gives us 4 minus 48 is negative 44, right? Is negative 44. So b squared minus 4ac is really less than 0. If b squared minus 4ac is less than 0, the negative discriminant shows that there are two imaginary solutions. There are two imaginary solutions. If the discriminant is negative, two imaginary solutions. So those solutions are complex conjugate of each other, right? So we can have both. Remember, the goal here was not to solve the equations. The goal was to identify how many solutions we can obtain and what type of solutions we could obtain. All right. Now let's see for in terms of the methods we're gonna use to solve some quadratic equations, we can use either of these methods. So it doesn't matter which one we're using, all right? So we can use a quadratic formula, we can use factoring property, we can use principal, square root principle, or completing the square principles. It all depends of the type of equations you have. You know, if it's easy to find two numbers when you multiply give you C, when you add give you B, you use the zero factor property. Most of all, that's what we're gonna use to solve the equations. Now, applications. We're gonna do some applications very quick of quadratic equations. Remember, this is something we use to solve some real life problems. In this example, so I'm gonna make it smaller so we have enough space to write everything. You know, okay, feel free to zoom and make it. I'm gonna make it okay, and a little bit higher. Okay, voilà, voilà. Ça c'est bien. Very well. That's in French. Ça c'est bien. That's very well. That's good. Okay. The formula, they give you a formula, 0.01 a squared plus 0.05 a plus 107 models a woman's normal systolic blood pressure, P. Okay, P is the systolic blood pressure at age A. P is the blood pressure, P is the age. Use this formula to find the age to the nearest year of a woman whose normal blood pressure, systolic blood pressure, is 115. So what do you think they ask you to find? Do they ask you to find A or P? And what's 115 represent? When you solve a problem, remember what we said. You need to read the problem multiple times to make sure that you understand what's the facts, what is given, and what you should looking for. After you do that, you should translate the English sentences into mathematical models. So because it's already translated, that's fine. Now, the equations you have, you need to solve. Because in this problem, it is stated that the systolic blood pressure is 150 milligram milligram high, I mean Hg. Now let's see. Let's see if we know B, then they ask you to find A. And we know A cannot be negative anyway, because it's the age of someone. If that person exists, then the age must be positive. So if you do 0.01 a squared plus 0.05 a plus 107 equal P, 115, right? We're gonna do it 115 that way. If you want, you can simply subtract 115 to both sides because it's an equation, it's a quadratic equation, so we know all the term must come to one side. So we end up having 0.01 a squared plus 0.05 a. What is 150 minus 17? It's only 8. And that's it. That's it. To solve this, we're going to use quadratic formula because quadratic formula is much easier to hear. You cannot say find two numbers when you multiply give you a negative. Oh no, you couldn't even do that because the coefficient of a square is not 1. And you cannot choose completing the score, otherwise you need to divide each term by 0.01. So what we're gonna do, remember here, we can say small a is 0.01, small b is 0.05, c is negative 8. So if you use quadratic formula, it's gonna give you a equal minus, remember you have x equal minus b plus n minus square root of b squared minus 4ac over 2a, right? Now let's do it here. We're gonna have negative 0.05 plus n minus square root 0.05 square minus 4 times 0.01 times negative 8 over 2 times 0.01, right? Now, when you do everything from your calculator, you should find 0.05 plus n minus square roots of 0.03225 over 0.02. Okay, now with this, remember this is two answers you must find. When you take the square roots of these two, what it's gonna give you? It's gonna give you A equal negative 0.05 plus n minus 0.568 over 0.02. All right. Now, two answers. Remember the first one you use the negative. And negative 30.9 because age cannot be negative. So you need to reject that one. Age cannot be negative. So you're gonna reject this one, right? Because it's negative. But let's check the second one. A is negative 0.05 plus 0.568 over 0.02. It gives us 25.9 that you can make it 26, right? Now, the positive solutions A equal 26 indicate that 26 is the approximate age of a woman whose normal systolic blood pressure is 115, all right? So approximately the age must be 26 years old, okay? So the 26 years old, I mean, it indicates that 26 is the approximate age of a woman whose normal systolic blood pressure is 115. You see, for the negative answer, we reject the negative answer. Why do we reject it? Well, we reject it because no one is born with negative age, unless your name is Benjamin Button, right? All right, that's a joke. Now, other problems we can solve using quadratic formula, it's Pythagorean theorem, right? So it's we use it. That's something from very old time. The ancient Greek philosopher and mathematician Pythagoras, I think it's been a long time ago, like before Christ, 582 and 500, founded a school whose motto was all is numbers. Pythagoras is best remembered for his work with the right triangle because this guy works with a lot of triangles. So triangles with one angle that is 90 degrees. You see, C here is 90 degrees. So this guy works with many things, but right triangle with one angle is 90 degrees was his specialty. So this side 90 opposite the 90 degrees is called what? You see, if you have the 90 degrees here, the side opposite to the 90 degrees, it's called hypotenuse. The other sides are called legs, so that's how we do it. So Pythagoras found that if he constructs squares on each of the legs as well as a larger square on the hypotenuse, the sum of the areas of the smaller squares is equal to the area of the larger squares. So, that's why we call it, relationship is usually stated in terms of the length of the three sides of a right triangle. We call that Pythagorean theorem. So the sum of the squares of the length of the legs of the right triangles equals the square of the legs of the hypotenuse. So hypotenuse, if the legs have length A, B, and the hypotenuse has length C, This is how it would define the formula. So the square of the length of the hypotenuse is equal to the sum sum of the square of the other two legs, right? So we call that Pythagorean theorem. And remember, the right angle opposite the hypotenuse. The hypotenuse is the longest side. Is the longest side is the hypotenuse. Remember that, okay? Now, we're gonna have we would have a chance to come back on Pythagorean theorem later because we cannot move forward doing all those pre-calculus calculus without using Pythagorean theorem, especially when we deal with trigonometry. But for now, let's just practice. We see here, they said the figure shows the dimensions of an old TV screen. What is the size of the screen? When they ask you for size, they mean you must find, you know, because we know the shortest two lengths because they tell us this length right there, this is, oh, I cannot even do it here. Let's see if I can do that. No, what? Okay, maybe this. See? So we have these two. All right. So let's call, if we call this one, we're gonna call this one A, and we're gonna call this one B. You see right there, we have A equal 19.2, and we have B equal 25.6. Right? So what they ask us to find is the size of the screen. So at this point, finding the hypotenuse gives us the diagonal. So that's what we need to find, right? Because we know the height, we know the length, but how about the diagonal? So what we need to do is to find the hypotenuse because we know c square, if I call this one c, equal a square plus b square. C square would be 19.2 power 2 plus 25.6 power 2. If we take the square roots of both sides, we know C would be, I don't need to put the negative side because we know we're not dealing with the negative. So 19.2 square plus 25.6 square, right? So with a calculator and doing everything, you should find C equals square roots of 124. When you take the square roots of 124, C equals 32 inches, right? So you can end up saying that the screen size, the screen is what? The screen is 32 inches, right? All right, so you see the importance of the Pythagorean theorem because that's something, you know, we're gonna use a lot in the future, especially when we do trigonometry. But for now, I'd like you to keep it in your notes and make sure that it's help you in the future. And also, of course, you can solve some quadratic equations from different formats. Always check your book. We're gonna come back for other types of equations because we have plenty of equations we can solve. In the meantime, and just this first chapter, don't forget this is part 2 of section 1.5 quadratic equations. So look out for the 1.5 part 1 as well. That's already posted. Take care. Have a good day.